Welcome back, my friends. We are looking at enhancing the Metro Map project from the WiByte Python curriculum available at www.wibyte.in. Previously, we calculated the fare of this, stations. Previously, we have been working on calculating the fare. We have kept a very simple scheme. The fare largely depends on the number of stations traveled. For example, if I go from, let's say, Spriteland to, say, maybe, broadcast. Let's say I go from Spriteland to now, previously we have looked at a very simple fare scheme where, let's say, for example, where the now previously we have looked at a simple fare scheme where the fare largely depends on the number of lines traveled. Of course, I add a bit of surcharge for crossing the station, but let's say I do not cross the Previously, we've looked at a simple scheme for calculating fares where fare depends largely on the number of stations traveled. Of course, I add a bit of surcharge for crossing the lines, but let's say I stay on the same line. Let's say I go from, Spriteland to, let's say, cloning. I calculate fare that comes out to be 100 rupees. That's because 1, 2, 3, 4, 5 stations. Likewise, if I go, say, from, say, Turtle Park to perhaps maybe, let's say, you know, say, uh, say while loop, then I will pay calculate fare. Again, it's 100 because 1, 2, 3, 4, 5, again 5 stops. But we can think of this differently. We can say that, look, in my network, one line is probably more expensive than the other. Now, this actually happens sometimes because perhaps one line takes you to a premium location, let's say like an airport, or perhaps maybe it goes through some very important part of the city, and hence you charge more for it. Now, in this video, we'll see how we can accommodate this situation. This is quite interesting actually, because now we have to figure out when we travel, how many stations are we traveling on each line. Let's see this for say, let's say for just two lines. It's kind of straightforward, but as we think of this for more and more lines, we have to think a little bit more carefully. So the bonus we are building here is that we say, okay, look, the fare depends on the line. For example, in our code, we say scratch line is, let's say, 20 rupees per station, but the Python line is, let's say, 30 rupees per station. So like I said, we need to figure out how many stations are we traveling on both the lines. We discussed before, there are two scenarios. Start line is same as the stop line, in which case we know which line we are talking of, and we can accordingly charge the ticket. On the other hand, let's say start line is not the same as stop line. Well, in this case, we need to find out which line are we starting with, which line are we ending with, which is the first line, which is the second line, because accordingly, I'll know how many stations I've traveled on, let's say, scratch line and on the Python line, and then I can compute the fares. Now, with two lines, which is what we're looking at, this is not too hard. All I can do is that, look, if my start line is the same as stop line, which is there's no interchange, then I compute the number of stops as earlier. But if this line was a scratch line, then I set this to a variable called, let's say, number of stops on scratch line, and number of stops on Python line automatically then becomes 0. Now notice this usage is interesting. I'm saying two variables separated by a comma, assigning them to two values also separated by a comma. So this says n stops SL is n stops PL is 0. On the other hand, if I have an interchange, well, I again figure out if my starting line is scratch line, then I know that the first, move towards this interchange is on the scratch line. The next move from the interchange to the, let's say, the destination station is on the Python line, and vice versa. Now I have a certain fare for both of these, and I compute the fare accordingly. Now for this, I'm not applying the base fare here because, this just adds complication without adding any further insight. So let's just implement this first, and then we'll come back and discuss this a bit more closely. So I come into my code. Like I said, I need to define a few variables here. I just say, well, look, n stops, let's say SL, n stops, say PL is both 0, 0 to start with. Now this is, like I said, very concise way of writing this code. I say, well, if there's no interchange, if start line is same as stop line, I ask myself a question. Well, if start line is, let's say, STN, underscore SL. So if that's a scratch line, then I know that my number of stops that I've traveled are entirely on the scratch line. So I just say number of stops SL. And in fact, I can just, take, let's say, this statement, copy and paste it. So say Control C. Be careful with the indentations here. Okay, don't need so many indentations. This is just nice. And I'm going to put an else over here. Say, well, else. Again, I paste this, but remember, I have to be careful here. So I say n stops is entirely on the scratch line. whereas here it is entirely on the Python line. So I just have to take care of this. On the other hand, if I have switched stations, then again I figure out if my first station was on the scratch line or on the Python line. If it's on the scratch line, so I just ask the same condition. If start line, let's say, is stnsl, well, in that case, I know that my first few stops have been traveled on the scratch line, so I just make it SL. Next few stops have been traveled on the Python line, but remember, this must be now removed because I'm just counting the number of stops that I'm traveling on both the lines. I'm not counting them all together like I was doing earlier. Else, which means I started from the Python line, well, these two will just reverse. So I'll just, copy this and say paste it here. Again, this has to become Python line because I'm starting there and ending up on, let's say, the scratch line. Now, having computed all this, like I said, I'm getting rid of this base fare here for this particular rule because it doesn't really add any value. So I just comment out all of this, and I'm just going to compute the fare now by saying, okay, look, fare is equal to, say, n stops, say, SL times, let's say, fare, say, increment fare, say, SL. We'll define this in a moment. And then likewise, let's say, n stops, let's say, PL times, say, INCR fare, say, PL. Now, of course, I need to define these two. So I say, well, increment fare on scratch line is, let's say, 20. Incremental fare on, let's say, Python line is, let's say, 30. And I can retain this, surcharge for crossing the lines. This we can. Now, when I run this piece of code, let's just test it. Let's say I go from spriteland to my blocks. Well, I'm staying entirely on the scratch line. When I calculate the fare, it tells me it's 120 rupees. That's because 6 stations, 20 rupees per station. But let's try the same distance on, let's say, the Python line. So I say, well, let me go from turtle path to, say, escape character. Here, if I click calculate fare, notice it comes to 180 because remember, Python line is now more expensive. It's 30 rupees per line. Let's say I switch lines. So I go from, say, say maybe Turtle Park to perhaps maybe Sprite Land. Now this, we'll see how it works out. When I calculate fare, it comes to 210 rupees. That's because I'm doing 1, 2, 3, 4 stations on the Python line. So that's 120. I'm doing 1, 2, 3, 4 stations on the scratch line. That's 80. So 200 and plus 20, say 10 rupees for the surcharge. Let's try a reverse example. Let's say I go from my blocks to, I start on the scratch line. So I go from my blocks to, let's say, say range. So that's like 1, 2 stations on the scratch line, 1, 2 stations on the Python line. So that's 40 plus 60, 100 plus 10 rupees. I expect the fare to be 110. And indeed, that's what it is. Now, this is quite nice, quite interesting. Before I wrap this up, however, let's ask ourselves, can this approach work if I have multiple lines? Now, this is going to be quite troublesome because the number of combinations just goes up, right? I cannot say, well, if the scratch line is not the starting line, then it must be the Python line. So I need to find a more robust way of finding where I start and which variables I'm updating. In fact, we will do this at a later time, but before I wrap this up, I just want to give you a glimpse on how that solution will work. Like I said, this approach we just saw is okay for 2 lines because, if not scratch line, then it has to be Python line. But as the number of network lines on the network increases, we need a cleaner and a more scalable approach. Otherwise, the code will get completely unreadable. Now, the solution to do this would be to use lists. In fact, what we can do is to create a list of all the lines. This will be a list of lists. We can also create, let's say, lists to hold the incremental fare as well as the number of stops traveled on every line. These can also be lists. In that case, we can address the lines with their indices on the, let's say, list of lines, and then we can keep the code flexible that way. So we don't have to hard code variables. We will use lists, use their indices, and build the code in a flexible manner. Now we will see this at a further enhancement where we'll generalize this code. But for now, I hope this gives you an idea. This is nice, simple to implement, and still works quite well. In general, if you think this way of learning by building activities, by enhancing them, is something that you enjoy, look at our website www.wibyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.